Okay, we have a fun integral here today from the Columbia Integration Bee 2025, number 15. We have the integral from 0 to pi over 6, the fourth root of cosine of the fourth x minus cosine 2x dx. Okay, at first it looks kind of scary because it's not that great dealing with the fourth power here, and we're not used to dealing with the fourth root. So there's a couple problems, but there's a kind of obvious place to start. We don't like having different angles. Things don't usually work out very well if they're different. I suppose you could try to convert this to a double angle. I don't know how that would work. I don't think that would be that great though. I want to convert this one. For cosine 2x, we can use the double angle formula for that. I know 3 versions of it, but what I think I want to use, I think this is going to work the best. I don't know. This seems like a good way. If we change this to 2 cosine squared minus 1, and then if I rewrite this whole thing, we'll distribute this minus sign, so we have cosine to the fourth x minus 2 cosine squared x. This becomes a plus 1 now. But then from here, we can factor this like a perfect square. I can write this as cosine squared x minus 1 all squared. But then from here, notice I can reverse the sign on it without changing it inside the square, because it's just gonna, if you have a minus 1, it's just gonna square to 1. So I can write this as 1 minus cosine squared all squared. But then, of course, we can use the identity on this and write that as sine squared. So we have sine squared x. So we have sine squared x squared inside the fourth root. So we can take this sine to the fourth x, but this thing right here is going to be inside the fourth root. So what comes out of this is going to be sine x, but we do need absolute value right now just because this thing can't be negative without even power here as the index. So we'll keep that for the moment. But the thing is, our bounds are going from 0 to pi over 6. Sine's always positive in that region, so we can just drop that and just go with sine x. So really we just had to do some trig, and we're putting this back in the integral, but now it's real easy because we're just integrating from 0 to pi over 6 sine x dx. Integrate, that's going to be minus cosine x from 0 to pi over 6. Plug in. Cosine pi over 6 is going to be square root of 3 over 2, so we have minus square root of 3 over 2. Then minus times minus is plus. Cosine at 0 is just 1. And so for my final solution on it, we just get 1 minus square root of 3 over 2. So for my final solution, we just get 1 minus. So for my final solution, we just get 1 minus square root of 3 over 2, and that's it. Okay, there you go. Good one today from Columbia Integration Bee 2025. Thanks everyone for watching. Have a good day.